Take a second to think about everything you've done today. You've taken in way more information than you could possibly remember in detail. Things you've seen, heard, smelled, touched, and tasted. But somehow, some information gets stored in a way that lets you access it later. So what makes this process work? Our brains are really complicated, so scientists have come up with models to represent how our brain takes in and makes sense of information in our environment. One of the most influential models is the information processing model, which proposes that our brains are similar to computers. We get input from the environment, process it, and output decisions. It's important to note that this model doesn't really describe where things happen in the brain. It's more conceptual. The first stage then is getting the input, which occurs in sensory memory. This is sometimes also called the sensory register. So if you hear that term, just know it's the same thing as sensory memory. And this is where you first interact with the information in your environment. It's a temporary register of all the information your senses are taking in. Even though you have 5 senses, the 2 most studied in terms of memory are sight and sound. So within sensory memory, you have iconic memory, which is memory for what you see, and echoic memory, which is memory for what you hear. One of the really interesting things about sensory memory is that it lasts a different amount of time depending on the modality of the information coming in. So visual information is incredibly vivid, but it only lasts for less than half a second. Auditory information, on the other hand, lasts a little bit longer. It lasts for about 3 or 4 seconds. So if you've ever tuned out of a conversation and your friend gets mad that you're not listening to them, you can thank echoic memory for helping you remember the last thing they actually said. So we have a ton of information coming into our sensory memory, but we can't possibly process all of it. We decide what to pay attention to, and that gets passed along into working memory to be processed. Working memory is just whatever you're thinking about right at this moment. It's also called short-term memory, but we're going to stick with working memory because that's what most psychologists call it. Working memory capacity works a little bit differently. It's not defined by time so much as quantity. Just remember the magic number 7. Your working memory can hold about 7 plus or minus 2 pieces of information at a time, so about 5 to 9. This does vary a little bit based on how complicated those pieces of information are, how old you are, that kind of thing. But generally, it's right around 7. And an interesting fact is that this is actually why phone numbers started out as 7 digits long. It was determined that that's as many pieces of information as a person could hold in mind without getting numbers confused or mixing them up. And just like sensory memory has different components for different types of input, working memory has different components to process those distinct types of input. Visual and spatial information, like pictures and maps, are processed in the aptly named visuospatial sketchpad, while verbal information, meaning words and numbers, are processed in the phonological loop. Again, think of repeating a phone number to yourself just long enough to type it in. That's using your phonological loop. Be careful here though. Verbal information means any words and numbers. So words and numbers you heard that came from the echoic memory and words and numbers you saw that came from iconic memory. So we've got a little bit of mix and match here. Now, you might be thinking that sometimes you need to process input that has verbal and visual information together, such as a map with street names and landmarks. In that case, you need someone to coordinate the efforts of the visuospatial sketchpad and the phonological loop. So something called the central executive fills that role. You can think of him kind of like a traffic cop who directs the other components of working memory. Once the central executive tells the visuospatial sketchpad and the phonological loop to coordinate, then they create an integrated representation that gets stored in the episodic buffer, which acts as a connector to long-term memory. Long-term memory is the final stage in the information processing model. When stuff gets in here, it's like hitting the save button on your computer. Unfortunately, our memories aren't quite as foolproof as that. It doesn't work perfectly, but we can store a lot of information in long-term memory. Once again, there are different components that specialize in different types of memories. We have 2 main categories: explicit, also called declarative, and implicit, also called non-declarative. As you can see, psychologists like to give these things multiple names, but fortunately they can generally be broken down into something that makes sense, so don't get intimidated. Explicit memories, for example, are facts or events that you can clearly or explicitly describe. So anytime you take a vocabulary test or remember the state capitals, you're using a specific type of explicit memory called semantic memory. And semantic just means having to do with words, so you can think about it as being able to remember simple facts like the meaning of words. A second type of explicit memory is called episodic memory, which is memory for events, like your last birthday party. Just like a TV episode is a sequence of events, your episodic memory stores event-related memories. While explicit memories are easy to define, implicit memories are a little bit fuzzier. They involve things you may not be able to articulate, such as how to ride a bicycle. You probably can't say clearly how much pressure to put on the pedals or exactly how to turn the handlebars, but provided that you ever learned in the first place, if you get on a bike and just do it, you probably won't fall over. Memories for procedures like riding a bike are conveniently called procedural memories. The last type of implicit memory is called priming, which means that previous experience influences your current interpretation of an event. For example, if I say the word hair, what do you think of? If you paid attention at the beginning of this video, then you might have thought of hair as H-A-R-E, meaning rabbit, because you were primed with the bunny picture at the beginning. Your recent experience of seeing a bunny stayed in your memory and influenced your interpretation of the word that I said. If you weren't paying attention, or if you maybe had to push your hair out of your face in the last few minutes, then you might have thought of hair as H-A-I-R, because it's generally a more common word. With all these components of memory, you might be wondering how much it can actually hold. I think we've all had the feeling that we can't possibly take in any more information. And while it might be true that you can't process any more information at the moment, unlike the computer in front of you, as far as we know, long-term memory capacity is unlimited. So your brain never actually gets too full for more information.